Here's our next example problem for solving quadratic absolute value equations. The absolute value of negative 2x squared minus 2x plus 5 is equal to 2x subtract 1. Now recall that this is absolute value. Therefore, we have to account for two possibilities. One is when we take negative 2x squared minus 2x plus 5 equals 2x subtract 1. So that's the equation that is present inside the absolute value. And the other one is if we consider the reflection of that. So it would be a negative times negative 2x squared minus 2x plus 5 equals 2x minus 1. Or if you prefer, 2x squared plus 2x minus 5 equals 2x minus 1. So we have to solve each one of these. And then when we find our solutions, we have to verify if those solutions are valid. Let's start with the one on the left-hand side. I'm going to group everything on the left-hand side of this equation. Negative 2x squared, subtract 4x, plus 6 is equal to 0. And it's probably easiest here if we just divide through by the leading coefficient of x squared, seeing that it's a factor in each one of these terms. So if we do that, we get x squared plus 2x minus 3 equals 0. This happens to be one of those very simple factoring problems. We need two numbers that multiply to give us a negative 3 and add to give us a positive 2. So x plus 3 is one possibility, and x minus 1 is another possibility. So we get x minus 3 times x plus 1 is equal to 0. And now we're going to need to solve for x. So taking the one on the left, x plus 3 equals 0, so therefore x equals negative 3. Your teacher may let you skip that first step. And solving the one on the right, we have x minus 1 equals 0, therefore x equals 1. So possible solutions 1 and 2. And now let's move our attention to the quadratic on the right-hand side. Once again, I'm going to group everything to the left of this equation. So we get 2x squared. We have plus 2x and a 2x on the right-hand side. So these two things are just going to add together to give us 0. So 2x squared minus 4 is equal to 0. We can see that I can easily divide through by a 2 here. So x squared minus 2 equals 0. X squared is equal to 2. And then we take the square root of both sides of this equation, being cognizant that we have to do positive and negative on the right-hand side. So our solutions are x equals plus or minus root of 2. And that gives us two possible answers that we have to check. All right. Next step is to go through each one of these four solutions and check them against our original. Okay, time to start checking each one of these solutions. Our first was x equals negative 3, so we're going to rewrite this original function, except everywhere that we see an x, we're going to substitute negative 3. All right. Now we can just do these calculations quickly on a calculator to the side. In doing so, I got the absolute value of negative 7 is equal to negative 7. So this is not true. The absolute value of negative 7 is positive 7, telling me that this first solution that we checked is extraneous. So it's a solution that we found to the quadratic on the previous page, but it's not a solution to the actual problem itself. X equals 1 was our next possibility. So negative 2 times 1 squared, subtract 2 times 1, plus 5 equals 2 times 1, subtract 1. And working these values out in a calculator, this time I got the absolute value of 1 is equal to 1, which is true. So x equals 1 is a valid solution. All right, moving on to the other solutions. Third possibility was x equals root of 2, which is approximately equal to 1.414. So once again, we're going to take the original quadratic absolute value function, and everywhere that we see an x, we're going to put in 1.414. And it is possible, depending on your teacher or your level, that you might have to use the actual value of root of 2 to do this, but for this point we're just going to approximate. I get the absolute value of negative 1.828 is equal to 1.828. That's a match. So the root of 2 is a valid solution. And here's our final possible solution to check. And I'm sure by now you're thrilled at the prospect of having to do all of this verification every time that we do one of these problems, but it is necessary to ensure that these solutions solve the original and are not extraneous. So the final check produces absolute value of 3.828 is equal to negative 3.828, which does not pass the check. So the absolute value can't produce a negative value. That means this one is also extraneous. So we only had two that worked. We had this, x equals 1. We had this, x equals root of 2. The first one was extraneous, and the final one that we checked was extraneous as well. So the actual answers to this problem are x equals 1 and x equals root of 2. The other two solutions were both extraneous, so they solve the quadratics that they happen to be involved in, but they don't solve our original problem. Okay, what does this mean in regards to the graph? Now, this is not something I would ask as a requirement for doing this question, but I just want to talk a little bit about conceptually, why do we get extraneous solutions when we solve this? I have the solution to this problem graphed, and I actually have it split onto a left-hand side and a right-hand side because I'm going to mark each one up individually. Okay, you'll recall that we had one solution of x equals 1. That is this solution right here. Where's that solution coming from? Well, you'll note it's on this portion of the absolute value function. Recall that the absolute value function can be written as a piecewise definition. Well, one part of that would be this quadratic, and where does it intersect that line? It intersects it at negative 3 and negative 7. And you might recall that x equals negative 3 was one of our extraneous solutions. This ended up being extraneous. It would have been a solution to the quadratic of y equals negative 2x squared, subtract 2x, plus 5. But what happened was, we applied the absolute value function to that quadratic. And when we applied the absolute value function to that quadratic, the part below the x-axis no longer existed, which made that solution extraneous. Okay, let's take a look at the other solution that we found. X equals root of 2, which as you recall approximated to 1.414. That solution was a part of the other quadratic, which could be determined using the piecewise definition. So it looked a little something like this. That quadratic is y equals 2x squared plus 2x minus 5. And it would intersect this quadratic at x equals negative root of 2. So this point ends up being negative 1.414 and negative 3.828. However, it is extraneous because this point no longer exists on the graph. What happened was we applied the absolute value function to this quadratic, and then that point isn't there anymore because that portion of the graph is now above the x-axis. So these extraneous solutions solve these quadratics, but they don't solve the absolute value quadratic. So there's a little overview of how those solutions map to the graphs, and that is solving absolute value quadratic equations.